Water? Nah, it's fine. Bro, why is it's so not sturdy? Okay, nah, it's fine. We chilling.
Just make sure the stream's going. Where's the?
Oh, it's set to wait.
You know how to fix it?
Yeah. Bro, what? Was it? We chilling. Wait, it's not this. It's not Catholic. Oh yeah, there we go. All right, then we're good. Really? No, I'm right. Look, it goes to red, bro. Are you sure? Are you sure? Okay. Okay, I have 3 minutes. I'll show. Should I turn on the webcam or no?
No.
No? Is webcam stuff?
It like covers the slides.
Oh, okay.
You get words like here.
Okay, okay, never mind then. You should.
You had been something, right? And then you had Miss and I saw.
Yeah, but that was good. The one they're talking Oh yeah, that page was easy. My page.
Me neither. Only grammar. That's it. I
One of the things I was able to complete last time, but this time I didn't.
For reading, I literally, hey, didn't you hear Miss Bachman's thing? Dang, you didn't stretch. Yeah, I don't know.
Let's fix it.
I know, I have to react to it though. I read kind of fast. I finished all the stuff. It's just the math. I stopped caring at the end, so then leave them on the internet. Also, with the math, like I know I learned it, but I forgot what Oh my god. Did you have to go to Zoom at like 10 to 11? No, it's like, it was like really like 8 to 8.
Okay. All right. It's 3:35. We're gonna start now. All right. Hi guys. I'm Daniel from FTC 479, one of the FTC teams here at Stuyvesant. And I'm going to be giving a presentation on machining and CNC. So some facts about me. I'm a junior here. I'm vice president of 479. Yeah, that's basically it. Louder? Okay. So, in this presentation, I'm going to talk about why you should CNC and how you'll do it, how to import a part into Fusion to get it prepared for CNC, and just general information about CNC routing. And also note down here, if you don't own the software I'm going to be talking about in here, which is Fusion 360 and Onshape, I think most of you can get a license for free because if you're a high school student, you get that educational license. First, I'm going to be talking about general manufacturing in robotics. Most common is 3D printing, which is by far the most accessible and cheapest out of these 4 methods. So it's also the most versatile. And then you have laser cutting, which we have a laser cutter over there. Use it to usually cut Delrin, wood, and acrylic. And it's usually used for rapid prototyping or yeah, just parts that you don't need that much strength on. Next is water jet cutting, which you can imagine it as laser cutting, but it can cut metal and other materials like carbon fiber. And this is what we're going to be talking about today for the CNC routing. I used to have CNC router here, but it's got moved up to the 4th floor robotics lab. And you usually use it to cut metals, plastics, and MDF, which I'll explain later. So what is machining in this lecture? I'm going to be referring to machining and CNC routing as the same thing in this lecture, which it's not, but CNC routing is a type of machining called subtractive manufacturing. And it's basically when you remove material from a bigger part to create a smaller part that has details on it. And usually you use metals like aluminum, steel, or brass, and plastics like polycarbonate because you can't cut those in a laser cutter. And I'm going to be using these 3 acronyms here. CAD, which is computer aided design. CNC, which is computer numerical control, basically meaning you design the part on a computer and you program a machine to perform operations on it. And then CAM, which is specifically how you set it up on the computer. So why should you machine? In FTC and FRC, it allows for more creativity when you're designing your robot. Like for example, on this robot you can see on the right here, this is our robot from Fright Frenzy last season. This would not be possible with COTS parts or channels from Go Build 'Em because you have these custom mounted screw holes that are not possible with channel. And you get tighter tolerances and it's more accurate to CAD because it links back to that other point where if you're CADing, you want to have the most control over what you want to design. So with channel, you're limited in that sense, but with custom parts, machine parts, you have tight tolerances, which means it'll be accurate, and you can design whatever you want. And this third point, easy transition from prototyping to the final product, kind of connects to how you use a laser printer or laser cutter to cut wooden parts to prototype, so you can do the rapid prototyping process. But then when you're finally ready and you're confident in your design, you can use that same part that you CADed earlier to machine the part. And these other points, basically I have to talk about them. You just get more flexibility overall and more customization. And also a large point for us, especially, is pocketing, which is essentially removing, you see these triangles here on the plate here, which you remove material to create these patterns, which can lighten the part, and it also looks really cool. So some tools that you use, the parts of a CNC router, you have the chuck, which attaches a spindle and it spins, and it holds the tool in place, so it allows the tool to spin. And then you have the bit, which a lot of people get these two terms mixed up. So a bit is used in lathes, drills for only boring holes. So and then an end mill, which is used in a CNC router, you use these to perform lateral cuts because they're built differently. And on an end mill and bits, but I'm talking about end mills here. You have flutes, and each flute is basically each of those spirals that you see on the end mill. So more flutes means you have you have more you have more heat and chip evacuation, but you have a weaker tool. And then usually for aluminum, use 2 to 3 flute for aluminum and polycarbonate, which are the two most common materials you'll be CNCing. Usually these end mills are made of carbide, which is a composite, but you have these cheap high-speed steel end mills that are used, but they break really easily and you usually don't want to use them. Generally, any variable in your tool is going to change the settings you want to set up in your CNC, and I'll talk about that later. And when you're CNC routing, you want to choose the type of material you want. So you have 505 to aluminum, which is a softer aluminum, but it's also cheaper. And usually you don't want to use it for robotics applications because it is weaker and softer. So if you machine a part with it, you can actually just bend it with your hand, which is not really good. So this is why we use 6061 aluminum, which is a little more expensive, but it's harder. And when you machine it, it doesn't gum up the end mill as much. Next, we have polycarbonate, or brand name. It's called Lexan. So it's a non-heat treatable plastic that you can CNC route, and you usually use it on parts where you want to see through that part, and just and then you have MDF, which is medium density fiberboard. It's usually what you'll be using as the bed of your CNC. So it's just a bunch of wood packed into like a board, and you use it because it's easy to cut and it won't like harm anything when you do cut it. And usually these are the 3 most common sources for material that you'll be using. You also can use SendCut Send as a stock purchaser if you have the discount, but it's not very common. And yeah, this is just a few of the plates that I first machined when I first got into it. This was done at the NYC First STEM Center at Cornell Tech over the summer. We built it. We machined these plates for our off-season bot, and actually one of these plates were mistakenly machined with 505-2 aluminum, which caused it to kind of gum up the end mill, and we had some problems with that. So let's get into designing a plate. So when you first design a plate, especially for an FTC drivetrain and FRC, you want to consider all the holes and slots that you'll need, like slots that you need to tension your belts on. And also for holes, you want to try to aim to have extra holes in case anything doesn't work out on your original design. Because you have to remember, CAD will not always 100% transfer to real life. You have problems like missing parts, like you didn't order the right part, or you'll just not have the part on hand. So you want to have extra screw holes so you have flexibility in that sense. And you always should fillet your part, which means you have these rounded corners here. If you see, all of these parts have rounded corners. And the reason you don't want sharp corners is that, first of all, it's dangerous. It's also not legal in FTC. And also, it's for inner corners that are sharp, is impossible to machine, because if you think about it, your bit or your end mill is going to be round, and you can't get that sharp, completely sharp corner. And you should always have pocketing when possible, especially on this outer plate, because first of all, it looks cool, and it also reduces the weight of your robot. On our inner plate, we do have this hole pattern that we use to mount stuff on, so we don't have that pocketing. But you see on our outer plate, we do have that because we had the opportunity to. So Personally, we use Onshape to CAD our robot, so it's the workflow is not completely smooth, but it's not that hard. So once you have a plate design in whatever CAD software, just for Onshape, it should be the same for all CAD software. Just right-click the part, click Export, and make sure you export it as a step file so you can import it into Fusion. And yeah, if you CAD your robot in Fusion 360, which I know some teams do, you can skip this step. So when you import into Fusion 360, just go to File, Open, and open from your computer. Choose the file. The thing is, if you have a large sheet of stock and you want to machine multiple parts, you should use the derive features in Fusion. And this is the same if you CAD your entire robot in Fusion too. And make sure before you do anything, make sure you're using the correct settings for Fusion, and make sure you're using the correct up and down axis for your machine, which means usually for most CNC machines, you have your Z axis as the up and down axis. So make sure that's calibrated correctly in your Fusion settings. You have to check your manual for that. And there's just I'm gonna start doing a live demo alongside this. So CAM, computer aided machining. So basically you import the part, and then you have to actually get ready to machine it, right? So you're gonna go into Fusion and you wanna create a sketch. So you see how on the top right here, the Z axis is the up and down axis, because that's the setting I use for my CNC router. So at the origin here, you want to create a sketch on the X and Y plane, create a rectangle, and dimension it however large your stock is. Okay. So let's say I have a 24 by 24 inch piece of aluminum here. So I just...
Can I have your attention? Camaro Noxie, please meet his teacher, Mr. Bianchi, at the first floor security desk.
Yeah, so I just make this this square here, and then after you want to extrude it so that it's the same thickness as the stock you're using. So make sure you have a caliper on hand to measure your stock, and also a tape measure to measure how wide it is. So usually for FTC plates, we'll use 1/8 aluminum. For FRC, I think you guys use 3/16 or 1/4, but those get a little heavy. So say 1/8 inch or 0.125 inch. And you'll see now we have a CAD model of our stock here. And notice how I'm currently on the top left, I'm in the design workspace. So what you want to do is switch over to manufactured when you actually get it set up. So let's export a plate that we want to use. So I'm going to use this from our summer off-season bot as an example. So you see how I export it as a step file. This is our outer plate for our drivetrain. So once you export it, it should download. Yep. And go to Fusion, File, Open, open from computer. Open this, and now you have this file in your CAM software. And you guys don't have to follow along, by the way. All of this is recorded, and the slides are going to be posted after. So, yeah, you can refer back to this. So after this, we use the insert derive tool. Let's save the design first. Let's test. Select source. Save it. Okay. Okay. Or another option is if you can't, okay, I don't know what's happening with the Fusion because it's linked to my cloud drive. It's probably dying right now. So another option is you just directly create the sketch in your CAD file. And you extrude it. And always make sure your document settings have the correct unit, right? So I think in America, most CNC machines use inches for whatever reason. So yeah, you're just forced to use inches. That's fine. And there's dimension wrong because I dimensioned it in meters. Alright, I guess there's a problem when you don't test drive your slideshow beforehand. So I'll just go on with the slideshow because I think the live demo is like die. So after if it worked, you would switch to your manufacturer workspace and then make sure your you click setup in the top left and make sure you fill in your machine WCS and model information. And like before, how I mentioned about the up and down axis, you have to make sure your model is oriented correctly. So make sure your plate is flat against your stock, like inside it, and not on top of it or perpendicular. And you should always choose your stock point as the corner at the origin. And then usually for a CNC machine, you'll zero the z-axis, right? So you'll zero it to the bottom of your bed. And then that's why you choose the bottom corner, because that's where your zero is. But if you do choose to zero your Z on top of your stock, that means you'll choose the top of your stock on Fusion also. So just make sure you have that set correctly. And also, on the last slide, see how there's a little extra space in between the stock model and the spots? You don't want that. So you want to go to the stock tab and click no additional stock. I'm just going over the most important settings to change right now so you won't have issues later. You'll always want to tune your settings slowly, but these are just the most important ones. And the possible operations, the most common operations you'll be using are bore and slot for, well, your screw holes and your slots. These are the ones you'll perform first because you want your screw holes so you'll be able to fasten the plate down. Second is pocket, which is for pockets. And then you have contour, which basically cuts only in an outline. You use it to cut out the plate, but also another application is using it to cut out like large pockets that you don't want to spend the time cutting the entire thing. So the concept is you'll drill holes inside those pockets in the center, you'll screw it down, and you'll just do a contour on the outside of the pocket. So you only have to cut the outline and not cut out the entire thing. And as a rule of thumb, you'll usually use smaller tools for your bar and slot. You'll want to use the largest tool you can that fits within your screw size. So let's say usually for FTC, you have 4mm holes for M4 screws. You'll use a 1/8 inch bit because that can fit within your hole. And you have larger tools for pocket and contour, and you can use a 1/4 inch end mill for that because the larger the tool, the more material you can take off at once, and it's also stronger, which means you can just force it to go faster. And these are some operation settings Yeah, always remember this. Consult someone experienced if you're unsure about anything. Like, you have to remember these machines are very dangerous, but not if you know what you're doing and you check everything. So make sure you check about something if you're not sure about it. And you have to remember the smallest change can result in humongous problems for you. Like I was talking about earlier, use the wrong type of stock, the end mill's gonna get gummed up, you're gonna start melting your material. And also, please use presets if your makerspace provides them. Like at Cornell Tech, they have presets for you if you want to machine something, and the mentors there are just willing to help you. Consult with a teacher at your school or your makerspace if you have a CNC machine there. And some specific options for bore to make everything faster, especially for the plate I showed earlier that had a bunch of screw holes in it. You want to select same diameter, which is over here. Basically what that means is once you click a hole, it'll also select all the holes of the same diameter. So if you have a bunch of M4 holes, you click one hole, all the other holes will also get added to your toolpath. And then for all of them, your offset tab, you should have your bottom height set as a very tiny negative number offset from the bottom. So you'll make sure that your part is completely cut out and you won't leave a tiny little film at the bottom. And some settings for pocket and contour. You always want to choose the bottom chains. So maybe you go under your plate and choose those chains at the bottom. So that means it'll actually machine to the bottom. And then these settings, don't copy them. It changes, like I said, every little change in your tool or settings, you have to like recalibrate it. So these are just the ones I used, but don't take these as a rule of thumb. Here's examples. For reference, I use these settings with a 1/4 carbide O-flute end mill. And yeah, just please remember, please experiment with your settings. It's like, you're not gonna get it perfect the first time. You're always gonna end up with bad parts. You're gonna end up with mistakes. There can be safety hazards. But once you experiment it and you perfect it, that's how you get like that high. And it's just really nice once you have a perfect setting tuned in and you just let a part go and it just does it. You know, also remember, undershoot your settings at first so you don't like break your machine. You always can buy more stock. It's like what, $30 a square foot, but a machine, like, yeah, you don't want to buy a new machine. And here are some extra considerations before you start your process. Make sure you fasten your part. So that means beforehand, drill a few holes with a hand drill into your part at the corners usually, so you have those anchors. So when the machine actually drills into it, it won't move around or vibrate that much. And this especially for circular parts, like if you're cutting out a flywheel like on this one, you always want to make sure you screw it down very hard so it doesn't get to spin around anyone. Make sure you always have it screwed at least four screws for each part. 2 screws is just not enough, I've found. Also for polycarbonate, it's just more flexible than aluminum, which means when you machine it, it'll vibrate up and down. And that can create a lot of heat, that can create a lot of noise, which you don't want, especially the heat, which means if you have too much heat, polycarbonate can actually melt because of how fast your end mill is spinning. Also remember, for some machines, please unlock the spindle and interlocks when you're starting the machine and lock them back when you're not, because if you don't unlock them, the machine's gonna break. And just lock them when you're not working. So like when you're changing the chuck or you're changing your end mill, always lock them so you don't like destroy your hand if it accidentally turns on. Always wear adequate PPE, like your goggles, your mask. I know I'm not wearing a mask right now, but I really recommend it if you're machining a part, especially for like if you don't have an enclosure for your CNC, like if it's a desktop CNC, you don't want to like breathe in any like dust or yeah, it's bad for you. Also, always follow safe procedures, listen to your mentors, and have your emergency stop ready to press at all times. And yeah, this is what I was talking about earlier. This is an example of what not to do. Because you see, I have only 2 screws on each part here, and they're very weak. These were not good screws. So when I did machine them, some of the parts, some of the pockets started spinning around, which and I think one actually flew out, which was a learning experience. So, you know, you don't want to go through that. Take it from me. I went through it. You don't want that. And here are just 2 examples of heat and chip evacuation.